In this video, I'm going to introduce a very simple risk assessment, and then I'll show you how to enter distributions into a risk assessment model. Imagine it's your job to arrange a crab cake lunch for your office. You're looking at a crab cake right now. I come from Baltimore, Maryland, and a crab cake is one of our local seafood delicacies. You've checked with your boss and you found out that in the past you get about 45 people to the luncheon, sometimes a little more, sometimes a little less. You made a few phone calls and today the cost of a crab cake meal is $22. So you estimate that the total cost of this luncheon will be $990. Your boss has made it very clear that if this thing runs over $1,100, the extra is going to have to come out of your pocket. So you figure it might be worth doing a little bit of risk assessment to see how this could turn out. So we're going to begin here with the things we're uncertain about. We don't know exactly how many people are going to come. It could be 45, could be more, could be less. So what I'm going to show you is how we can replace a point estimate like this with a distribution. Now the way we're going to do that is we're going to go to the Define Distributions icon, click on it, and it opens up this window. And this palette shows us all of the distributions that are available in the at-risk program. I don't want you to worry about the distributions, what they are or why I choose what I choose right now. All we want to do is learn how to put a distribution into our model. But do notice that there are a number of tabs up here. There are the commonly used distributions. There are the discrete distributions. Notice they're all red. There are continuous distributions. They're all blue. And we'll skip over here to all distributions. Because for this particular value, I'm going to use a Poisson distribution. So when I click on it, double click on it actually, a window pops up. And it has a picture in it already. And you might think that the software is smart and it knows what the distribution should be. It's not. Every time you open a distribution, there's a picture there, and it uses default values, or sometimes it uses a value that is in the cell that you've identified. So I'll explain that in a second. But let's go up to the top and work our way down. First, we see up here the name. The name is taken from text that's near your cell. At risk will look first to the left, then on top, and then it begins to look other places to find some text to use to describe the distribution. In the second line is the cell formula. Once you learn the syntax of at risk, you can just type in the cell formula. Down here on the left, below this cell formula, we see an important bit of information. What you're going to find here is the distribution name, and you will see the function as well as its name, and you'll learn later that you can pull up different distributions from this window, but right now Poisson is exactly what we want. And then it identifies the parameters that are needed to define a Poisson distribution. And in this case, it's a lambda. So you don't know what a lambda is, more than likely. We learned what means are and standard deviations, minimums and maximums, but not lambda. Well, as it turns out, lambda is just the expected value of a Poisson distribution. And the default value in here is 1, and I don't want that. The default value is 45. I think it's 45. And as soon as I do that, by the way, you see a distribution here. Notice this distribution allows that it could be many different numbers of people that come. On the left, it could be as few as 0, although those numbers are not very likely. In fact, numbers less than 30 are not terribly likely. And skipping to the far right, numbers greater than 60 are not terribly likely. But this allows for the fact that we don't know for sure what that number is. There's a variable number of people that comes each year. And now I have captured that, so all I have to do is say OK. And now that 45 has turned blue, and that indicates that there is now a distribution in here. By the way, This static number, where it says static, that's basically saying when the model is sitting at rest, the number that will display in this cell will be 45. Okay, let's try another. The cost per person is unknown because the cost of a crab cake meal is market-based. Every day it varies. So we're going to go up again to our defined distribution. And this time we're going to use a continuous distribution because we are going to treat money as if it's a continuous variable. Any value at all will be possible in the range I'm about to define. We'll just round it off to the cents. This time I'm going to use a uniform distribution. I double click on it and up comes a default picture, and there are numbers up here in the parameter windows that look a lot closer to where we're working. 19.8 and 24.2, but notice it's using the 22 that we have, and that's a static value. But these are not the minimums I want, because when I called around to the restaurants, I found out it's not going to be less than $20, but it could be as much as 35. And so now I have a distribution from 20 to 35. Any value in there is as likely as any other. So now I'm going to hit OK, and we have taken 2 point estimates and replaced them by distributions. If I turn on my Monte Carlo process, the dice here, if I click on this, and I have to widen that cell so you can see the answer, we immediately see that, it is possible this could cost more than $1,100. So that's going to be of some concern to me. But we'll run this risk assessment in another video.